Hello everyone and welcome back to NotesNaka. In this video, we're going to talk about the fundamental steps of DIP, in which the first step is image acquisition. So this is what we will be talking about in this video. What image acquisition means is getting the image. Before we do anything, any processing on our image, first we need to get the image and then only we can do anything. So in this step, two steps are done, capturing and digitizing. So let's discuss these two both. So first, capturing. So how is an image captured or image is formed? So basically an image is captured. Suppose we have a sensor. It can be a sensor of our eye or a camera. The basic of how images are captured remains the same. So we have a sensor and we have an image. When light falls on the image, then the sensor captures the image and then it forms it in its whatever it is, the sensor, and then it extracts the information. It sends the electronic signal. Here electronic signals are generated and this is sent for further processing. So basically a sensor takes the image whenever light falls on it so that the image can be seen. So that is how an image is formed, and then it gives off electrical signals and then further processing is done on it. And the second step was digitizing. For digitizing, so when an image is formed, it gives us electronic signals. They are basically in the form of analog signals. So now we have to change it into digital form so that we can further process it. So the process of changing an analog image to digital image is sampling and quantization. These are two processes that are used to do this. So what sampling and quantization means is, first let us understand how an image is represented. So it is represented in a form of 2D plane. So we have our x-axis and our y-axis and we have an image on it. So basically this image has two things. It has coordinates and it has an amplitude or an intensity. So suppose this place is more intense and this is less. So this is more black and this is white or something like that. So that is what amplitude or intensity means. And the second thing is it has coordinates. So it has two things. Now sampling basically means digitizing the coordinates. We have to change both of these things to form our digital image. So to do that, first sampling is done on the coordinates so that the coordinates can be digitized, and then quantization is done so that the amplitude or the intensity of the values can be digitized. So these are the two steps, and now let's discuss these two steps. So first of all, sampling. So this is our analog signal. Analog signals look like these. So for sampling, what we basically do, the basic concept is that these are divided into small parts. All of these are divided into small parts, and it depends on various factors on how much parts is it divided in and how much should be the gap between two parts. These all depend on many factors, but the basic concept is that it is broken down into small pieces like these. And after that, what happens is we get something like this and this. So basically we have sampled it goes like this. So basically we have sampled our analog signal and we have small pieces of information. Now what we do after that is quantization. So we have changed the coordinates into digital form. Now we are trying to change the each and every value, the amplitudes, into a digital form. So let's take a 3-bit quantizer. 3-bit quantizer means we can only use 0 and 1, and we're taking 3 bits, we have these combinations. So we have our sample data like this, and what we do basically is, for every one of these samples we find out the value corresponding to it. So this one corresponds 001, so we will have our answer as 010, and then this one will have this answer 001, and then this one will have 000 or something like this. So precisely we get a value, and this is now a So we have converted our entire image into digital form, that is the form of 0 and 1. That is what we had discussed before too, right? A digital image is a two-dimensional image of normally binary. So we have numerically represented our entire image in the form of zeros and ones. For example, we can see this is an analog image. Suppose it is an analog image, and if we want to change it into digital image, the first thing that will happen is this will be divided into pixels, and then this entire will be mapped over here. So basically we'll have something like this, and all of this will be colored. So this is how we are representing the image. And then after that, what happens, it for every value of it, it goes and checks the amplitude. I mean the intensity is given a value. And how are these values given? For that we have to first understand what is gray level. So let's try and understand what is gray levels. So gray level or gray value. Gray level or gray value indicates the brightness of a pixel. It tells us how bright or dark the pixel is. Our image is represented by a function fxy. We know this point. And if we want to represent it with 2-bit, we have 0 and 1. So 0 will mean black and 1 will mean white. So basically we have an image like this, and suppose it has pixels like this. So suppose this pixel is 0, this pixel is 0, and this pixel is 0, and other are 1. So 0 will basically mean black and 1 will mean white. So this image is only built of 2 bits, but in general term we have more bits. And suppose if we have 8-bit image in a grayscale, so we have 0 to 255 combinations that we can make. So what this means is when you start from 0 and go till 255, as you go this side, the intensity of the gray level will increase. Intensity of gray level increasing means that white is more penetrated inside it. When white is penetrating it, means that the black will be less darker. So the gray level intensity will start increasing. That means 0 will be black and 255 will be white completely. So similarly in this one, it will be first sampled, and then we have the coordinate values, and after getting the coordinate values, what we do is we quantize it. Quantizing means for every pixel we assign some gray value, and it gives us the intensity of that particular pixel, and forming everything making everything come together, we have an image at the end. And there is a Max-Lloyd algorithm too. Quantization level and sampling distance should be chosen in such a way that there remains the least error. That means the minimal to no change in the image. So the quantization levels, like we took 8-bit for 0 to 255 or whatever we take, and also in the sampling distance, when we take the distance, this should be chosen in such a way that it gives the least error. So this is also an algorithm that we should keep in mind while we are doing sampling and quantization. So this is basically the first point that we have, the image acquisition. So we capture the image and then digitize the image using sampling and quantization. And after that, at the end, what we do is we find out the problem domain. I mean, we have the image now. What do we want to do with the image? We want to enhance it, we want to restore it. What is the thing that we have to do in the image? So that is called as problem domain statement, and on basis of that, then we apply the further steps. So this was all about all about image acquisition, and I hope this was a pretty good explanation. If you like this video, then please give us a thumbs up. Also subscribe to our channel, and in the next video we will get started with the next topic. Thank you for watching, and bye bye. Take care.